So now what we want to look at is standard deviation and variance. And when we look at our data, you can get data that has same number of data points. There might be 20 people, 20 different estimates that were made, and then they all have the same average, the same median. So the guess that was made from the 20 people we just chose had a median of 612.5 people at the game. We might survey another 20 people and get the same median. We might even get the same mode. But our data could be far further spread out, right? We could get a whack of people that estimated way at the low end of 200 to 300 people, a whack of people that estimated way at the high end, 800 to 1,000 people. That tells us that the data, even though our median might be the same, our mode might be the same, it tells us that our data is significantly different. And it's important to be able to recognize differences between data. So we need to look at other means of measuring large numbers of data. And that's where standard deviation and variance comes in. So the note reads, the measures of spread or dispersion of a data set are quantities that indicate how closely a set of data clusters around its center. A deviation is the difference between an individual value in a set of data and the mean for the data, right? So we're going to have a low deviation if most of the data is clustered around the median. If the data is really far spread out, a whack to the left and a whack to the right, that's going to give us a much higher deviation that exists. So we've got two different formulas. Again, there's this idea of a sample size versus the entire population. So most of the time that we're using data, we're going to try to take a sample of data, analyze that, and have it represent the entire population. At the football game, we only asked 20 individuals to get their estimate. We didn't ask all 600 or 700 or 1,000 people for the estimate. So just at this point, the difference between a population and a sample is simply denoted by mu, which is for the population, x bar for the sample. That's the same that we've seen so far. Later on, we're going to see that there's actually a different formula. So values that are less than the mean. So in our example, we had 612.5 was the mean. If I guessed 200, I would have a negative deviation. I was lower than the mean, and values that are greater than the mean are going to have a positive deviation. So at this point, we're going to be asked to calculate the deviations for the data by going back to our first page. Okay, so that's why there were extra columns. So we're just going to do calculate the deviations. So we're going to go back to our first page and calculate the deviations on this chart. So in this case, yes.
What is that little
the bar?
U mean or something, and then the X with the line on it. What is it?
That's the mean. So mu. Let's come back here. Great question. So mu is the mean of a population, and x bar is the mean for a sample. So what we just did back there is we calculated the mean for a sample. So we calculated x bar because there were only 20 estimates that were there. So that was the x bar. So coming back to page 1, we're now going to enter a column, which is our deviation. So because this is a sample, we're going to take our value x and subtract the mean x bar. We calculated our x bar to be, was it 612.5? Is that right? On the previous page? 612.5. So I'm going to take 275, subtract 612.5, and that gives me minus 352.5. My second value of x is 400. I subtract 612.5, and that gives me a negative 212.5. I'm worried that my sheet here has got the wrong data. Okay, so what's 275 subtract 612.5? Someone do that?
Negative 337.
337? 37.5, and then that's minus 212.5. Okay, so what we're doing is we're taking our value, our x value, 275, we're subtracting our mean, which we calculated to be 612.5. I'm just going to confirm that. Our mean, quartile 2, 612.5. This is equal to our mean of the population. And I'll pause the video right now. We're just going to go through and fill out that entire chart. Made a mistake here. So I was looking at this page here, and I was saying the median is between 10 and 11. I'm talking, this is the median value. That's not median. We're looking for the mean. The mean we've calculated on our first page. Our mean is 627.5. So it's still x minus x bar, which is our mean. And our mean has a value of 627.5. So when we calculate the deviation of our first data point, 275, that becomes, let's write that in here, that's 275 subtract 627.5, which is equal to minus 352.5. Our second data point becomes minus 227.5. And now you can go through and fill out this chart. All right, so we've calculated the deviations. So now we're going to come back to page 3. And they note it is not possible to find the average deviation of a set of data since the positive and negative deviations will cancel each other out. If we take a look here, you know, the first half of our data are all negative values. The second half are all positive values. And they're centered around the median. So essentially the top half, if we added all those up together and we added all the numbers on the bottom half, they're going to essentially equal the one is going to be the negative number, and then the top half will be the same number but positive. So we added a negative 250 plus 250, that adds up to 0. So our average would be 0. So we can't do that. That's not a way to calculate the average of these deviations.
Can we not just do like the absolute value?
That's what I would. What I would have thought. But for some reason, it becomes a square of the value, which I guess what that means is that as something is further away from the mean, it has a more significant impact on it. So that's the right approach that you mentioned. But instead what we do is we use the mean of the squares of the deviation. So we square the deviation, and then we calculate the average of that. We calculate the mean of those squares. So what that means is we're now going to add our next column, and this is the way we always calculate our standard deviations. We're now going to add another column, which is x minus the mean, and we're going to square that. So we take minus 352.5, and we square that value, and that gives me 124,256.75, no, 0.25. So we now go through this entire column and we square every single number and we add that to this column. I'll pause the video again as we go through and fill in the squares of that data.